Shane here. This is our first lecture video. I'm going to cover 4.1, 4.2, and 4.3. Here we're getting into solving systems of linear equations, basically. There's essentially three topics in these sections. We're going to be solving a system using a technique called substitution. We're then going to learn how to solve a system of equations using a technique called the addition method or the elimination method. And then we'll also need to know how to apply those methods within the context of a word problem. So we're actually going to start with the word problem. Example 1, some of the vocab we're going to learn here is system of linear equations. I need to explain what that is, and also the substitution method. We're going to start with that. So this context says Florida has 28 fewer electoral votes for president than California. So our country has this weird system where we go to vote, and then depending on how many votes a candidate gets, he or she will get a number of electoral votes from each state. And those electoral votes are actually what are counted and what matter as far as who wins the presidency. Kind of a strange system, but that's the one we have currently. It says Florida has 28 fewer electoral votes for president than California. And then it goes on to say if the total number of electoral votes for president is 82, and that would be between those two states, find the number of electoral votes for California and Florida. All right, so just to kind of sketch this, we know that there's 82 total, and we don't know how to distribute them. If this is California and this is Florida, maybe California has, 60? And then Florida, in that case, if the total is 82, Florida would need 22 in that case. But we don't know yet if that's the actual solution. Right now, we just know that's a possibility. If California had 61 electoral votes, then to add up to 82, Florida would have 21. And so on. Probably not realistic, but if California had 1 electoral vote, then Florida would have 81. All right. So we're not going to do it this way. You could do it this way, though, to be honest. But I'm going to show you a more kind of technical or algebraic way. So the first thing I do is read the problem and read it again. So maybe I'll read it again. It says Florida has 28 fewer electoral votes for president than California. If the total number of electoral votes for president is 82, find the number of electoral votes, it should say, for California and Florida. So after you read and reread, the first thing you want to do is figure out what you're looking for, like what the goal of the problem is. Once you know what the goal of the problem is, then you're going to assign variables that speak to what you're looking for. So in this case, we're looking for the number of electoral votes for California and the number of electoral votes for Florida. So what I'll do is I'll assign variables to those things. So I'll call X, and this kind of weird equal sign means defined as. So X, I will define that as the number of, I'll just say EV for California. I'll let Y be defined as the number of electoral votes for Florida. So that's kind of step 2. So step 1, read, reread. Step 2, define variables for the thing that the problem is suggesting we find. And then step 3 can sometimes be challenging, is write equations that speak to the problem. All right, so just to reread the first sentence, it says Florida has 28 fewer electoral votes for president than California. So in other words, if I take California, sorry, I should be using my X. So here's the number of electoral votes for California. It said if I reduce that by 28, then I get Florida's number, right? Florida has 28 fewer electoral votes for president than California, right? California, take away 28, we get Florida. That's the first sentence translated into algebra. The second sentence says if the total number of electoral votes for president is 82, find the number, right? So that is our second equation, actually. So I would know that X, or California, if I add that to Y, the number for Florida, then I should get 82. And this is a system of linear equations here. So a system of linear equations is basically one or more linear equations. And within that system, you'll have maybe a solution. So we're going to see if this one has a solution. The first technique we're going to use is called the substitution method. So literally, y is x minus 28 for this problem. So what I can do is plug in x minus 28 into y. Right? Because literally y is x minus 28. What I can do is replace y with x minus 28. So I can say x plus x minus 28 should be equal to 82. Right? This is where y used to be. Now I have this linear equation and one unknown. So 2x, x plus x, minus 28 equals 82. Add 28. (82) plus 28 is 110. 2x equals 110. Divide by 2. So in other words, x equals 55, and that is the number of electoral votes for California. So if I want to find Florida's value now, I know that y equals 55, x minus 28, right? So 55 minus 28. So I'm now replacing x with 55. So 55 minus 28, we get 27. So I'll just kind of make it clear what I'm counting. This is electoral votes for California. All right, example 2 is requires a similar process, right? But it's a very different context, but very similar method. So what I'll do is I'll leave this open, similar to like how I did in class. And after you finish watching the video, what I encourage you to do is work on the open problems. And what I'll do is I'll post a document alongside the video with the solutions to everything. And that way you can get a little practice and then get some feedback. Kind of like how we were doing things in class. So I'll go on to page 63. So no longer a word problem. This is just a straight up math for math's sake problem. So it says solve by the substitution method. So again, just like we did, I substituted one into the other. What's being suggested here is, hey, y is this? 5x minus 13 for this problem. So if I take 5x minus 13, and plug it into y, then I'm using this substitution method. Right, I'm substituting that in, so I'll have 2x plus 3 times 5x minus 13 equals 12. Right, this is where y used to be, because I have, again, y equals. All right, so solve for x, distribute 3, I'll have 2x plus 15x minus 39 equals 12. Combine like terms, I have 17x minus 39 equals 12. Add 39. 17x equals 39. Sorry, not 39, but 51, right? Because I'm adding 39 to 12. And then divide by 17. 17 goes into 51 3 times, I believe, which always is a weird one for me. I don't know why, but yeah. So x equals 3. And plug that x in here, and then that'll quickly tell me y. So y equals 5 times 3 minus 13. So we have 15 minus 13. In other words, y equals 2. So this is the solution. You can leave it split, or it's this ordered pair, 3, 2. So you can write your solution either that way or that way. And I encourage you to check your answers here. It should be that when plugged in, if this is truly the solution, that when we plug this back into the system, we'll get a true statement. So is 2 equal to 5 times 3 minus 13? And then plugging in the same point to the other equation, we should get a true statement as well, or else this is not the solution. Is that equal to 12? So let's see, 2 equals 15 minus 13. Yes, it does. 6 plus 6 equals 12. So it needs to be true for both, or else this would not be the solution. So I'm leaving this one open. Just a quick hint. In the one we just did, y was already alone. So if a variable is not already alone right up front, you want to use algebra to get that variable alone. So one way to do that in this problem, if you add y, you would have x equals y plus 3, and then you could take y plus 3 and plug it in for x, since that's what x equals. And I'll let you take it from there. So page 64 is where we switch methods. I'm going to skip this one. I'll leave that open. I'll come back and do it, and I'll attach that document with solutions alongside the video. This one here, we're learning this addition method, also sometimes called the elimination method, because really we're going to use addition to get something to eliminate. So that's really why it's sometimes called either. So here's our system. You could absolutely solve this system with substitution. So it's not as though addition only works in this case or something. You have options. So if you like the addition method better, you can just solve systems that way. But any system can be solved a multitude of different ways. So what I want to do is get this system in standard form. Actually, this equation that I'm skipping is in standard form. So I have xy equals a number. I don't have that here. So I'll bring things over, I'll get that standard form. So I will subtract 3y from this first one. I'll add 3x for the second one. So I can write 2x minus 3y equals 9. That's my first equation there in standard form now. And then 3x plus 4y equals 8. All right, so what I want to do is add these equations together and hope that something gets eliminated. So literally, kind of strange, but I'm going to add these together. If I do that, I get 5x plus y equals 17. Nothing got eliminated. That means that we need to try something else. If we just add them, nothing gets eliminated, but we want something to be eliminated. So I'll just say it didn't work. So we're not only allowed to just add them together, we're also allowed to multiply the equations by any non-zero number and then add. So I can, for instance, like multiply this first one by 2 and the second one by -2 and then add them together. Or I can multiply the first one by 1/6 and then add them together. So I'm allowed to multiply by a number, and then I'm allowed to add those multiples to other equations. If that was a lot, please hit rewind. That's the beauty of YouTube, I guess. So what I want to do is actually create opposites. So the reason why nothing got eliminated is because I didn't have opposites. So just focusing maybe on x, I have a 2 and a 3. So maybe I'll turn this into a -6 and I'll turn this into a +6. Right? So I'm allowed to multiply this first equation by -3 to make my -6 here. And then I'm allowed to multiply the second equation by 2 to get my +6 here. So after we do that, I'll distribute all the way through. We get -6x plus 9y equals -27, also multiplying 9 by -3. 2 times 3x is 6x plus 8y, right? Distributing all the way through equals 16. Now when I add, these x's will go away. So I just won't write anything there. -6x plus 6x is 0x, in other words, 0. And then I get 17y equals -11, it looks like. So because of this addition, the x variable was eliminated, quote unquote. Okay, now I can just solve for y as we normally do. So y equals -11/17, apparently. And what I'll do is I'll go back now, and instead of eliminating x, I'll try to eliminate y's. So we had 2x minus 3y equals 9. And then we have 3x plus 4y equals 8. I'm just going back to this, or this, right? So now to eliminate y's, it looks like I can make this a -12 and this a +12. So I'll multiply this by 4. I'll multiply this by 3. So we get 8x minus 12y equals 36. And then I get 9x plus 12y equals 24. Now when I add, the y's will be eliminated. And I'll be left with 17x equals 60. Divide by 17. So x equals 60/17. This would be the solution to that system. Excuse me. All right, so you'll go back and do this one with the addition method. Let's see, okay, one more, it's another word problem. Okay, so it says each course at Mount Regis College is worth either 3 or 4 credits. The members of the men's swim team are taking a total of 48 courses that are worth a total of 155 credits. How many 3-credit courses and how many 4-credit courses are being taken? So in that last sentence is what we're looking for. So I'll let X be represented by this number of 3-credit courses, and then I'll have Y represent the number of 4-credit. I guess I'll just say courses, just to be totally clear. So once you know what you're looking for, assign variables, right? I'm going through these steps again. Once you assign variables, then go back to the problem and try to write equations that speak to the given information. Okay, so it said the members of the men's swim team are taking a total of 48 courses. So I know if I take X plus Y, I should get 48. And I also know that there are a total of 155 credits for those. So if I multiply by 3, the number of 3-credit courses, and then add multiplying by 4, the number of 4-credit courses, if this is now a number of credits, it should total up to 155. It's totally up to you how you want to solve this system now. I like substitution. I'll go ahead and subtract Y from both sides. So this first one, I'll get X equals 48 minus Y. Using substitution, I can then replace this occurrence of X with 48 minus Y. So 3 times 48 minus Y plus 4Y equals 155. Distribute. So I get 144 minus 3Y plus 4Y equals 155. Solve for Y. Subtract 144. So also I can combine like terms. It looks like I get Y equals 11. So we just found that they're taking 11 4-credit courses, right? I know that this adds up to 48. So if I want to figure out X, I can take 48 and subtract 11, right? I'm taking this 11 and plugging it in there now. So 48 minus 11 is 37. So this would be 37 3-credit courses. And we'd have Y equals 11 4-credit courses. All right, so I'm leaving page 66 open. As I've been saying, I will come back. What I'll do now is basically go through the problems I didn't do. And what I'll do is post a document, a PDF, alongside the video with the solutions to all these problems. So you can, obviously the video is about to end. What you'll do now is work on these problems that are open and then check your work with that key. All right. Hopefully this worked out for you guys. Hang in there. All right. Talk to you soon.